All right, we're looking at linear program example 3. So this program is slightly different, or a slight modification from before. So here we're trying to fill an order of 3,000 Model 1s or M1s, 2,000 Model 2s, and 900 Model 3s. And we can produce those in-house. And it requires wiring and harnessing to produce each of those. So we have this information here of how much it costs us to produce it. However, even with all of our constraints, we're not going to be able to fulfill that order because we are constrained with the number of hours of wiring and harnessing. So instead of making it ourselves, we can outsource it or subcontract it out and buy it. And so for us to make each unit, here is the cost, and for us to outsource or to subcontract, here are the additional costs to buy that unit. And so the new wrinkle for this problem is that we can either make it or buy it. So let's look to see how we set up a linear program for that. Well, here we have 6 new variables. One is we can make M1 or Model 1, we can make Model 2, make Model 3, or we can buy it. So those are our 6 variables. We want to minimize the cost to fulfill this order, so we have the cost of each one that we're trying to do, 50x1 plus 83x2, so on. And then here our constraints are we need to fill the order. We need 3,000 units of Model 1. We need 2,000 of Model 2. We need 900 of Model 3. So we can either make them or buy them, but we need at least that many. For wiring, these are our traditional constraints we've had before, is we can't exceed the number of hours we have for wiring or harnessing. So let's see how we set this up in Excel. All right, so the first thing I'm going to do is I'm actually going to just copy and paste the information over here. So that came straight out of Excel. Okay, and just modify it just a little to see what we're going to do. All right, and so here's what we have. So I'm just going to copy these, paste that over here, and then I'm going to delete all this and say that this is the number to make or buy. And then these are going to be my 3 or 6 X's. So I'm going to highlight those in blue so I can make Model 1, that's X1, Model 2, so on and so forth. All right. And now I want to see how much does it cost me to do each of these. So I'm going to, let's insert some cells here. So cost to make or buy. Okay, so to make it's going to be 50, 83, 130, 61, 97, 145. And that's what I'm pulling straight off of there. And so I'm trying to minimize the costs. So here are my total costs. And that is going to be simply the sum product. And here's the nice thing about sum products. I can highlight these 6 cells, comma, these 6. And that's going to take the top left, multiply it by the top left, add the middle, or top middle to the top middle, so on and so forth. So I get the amount. And this is my objective function. Okay, and I can do that using sum product. All right, so now that I have that, now let's look at our constraints. So the constraints that I have are my wiring constraints. So I'm going to delete these right here real quick. All right, so I need to have my wiring. So this is hours used, hours available, all right, similar to that we had before. So hours available is I have 10,000 hours here and 5,000 hours here. The hours used is equal to the sum product of these ones, comma, and now these are just the ones that I'm making. So I'm going to anchor the ones that I'm making, all right, because it's only the ones I'm making. If I buy them, I don't have to use my wiring or harnessing hours. So now I can copy that and paste that here. And so here are my first set of constraints. Or I guess in the way I wrote it down, these were the second set of constraints. All right, next is I need to create, so the order number, okay, and then the amount produced. So the amount produced is equal to x1 plus x2, or x1 plus x4, those that I do, or those that I either make or buy, and I need at least 3,000 of those. And I can do that same thing here, copy and paste those over. I need 2,000 of those and 900 of those. So this is constraints 1 and 2 that I wrote down in the linear program, that these need to be greater than or equal. So this is all in different lettering. Let's all change it. Calibri 11. And there we go. So now I have it all set up. So I'm going to come to Solver. I'm going to minimize total costs by changing all 6 variables. My constraints are that each of these need to be equal to the number ordered. So I have to fill the order. And then I need to be below the hours available for the ones that I make. Switch to Simplex LP. Click Solve. And there is the solution that we have right there. I'm going to make all of Model 1 and all of Model 3. I'm going to make as much as I can in Model 2, but then I'm going to outsource it out such that I'm actually going to be buying Model 2 from a subcontractor. I run my sensitivity report. And here's where I get this. So I'm going to grab this real quick and just copy and paste it over here. And here's the nice thing is the shadow price. Okay, so this is amount produced in Model 1. So if they want more than 3,000 units of Model 1, so they say we want 3,001, it's going to raise my cost by $57. So I need to charge at least that. If they want more of Model 2, it's going to cost me $97 because right now, notice that I'm buying it. So shadow price at most is going to be $97. I'm going to subcontract that out. For Model 3, so here is Model 3, is for me to increase my amount, I need to, it's going to increase my cost by $137. Now for my constraints, if you allow me more hours of harnessing, it's not going to change my cost at all. But if you give me more hours of wiring, it's not going to change my cost at all. But if you give me more hours of harnessing, then for every additional hour, I can reduce my cost by $7. And here are the allowable increases and decreases. And there's the linear program example for example number 3.